Hey everybody, in this example 3 in this video, we are going to go over an example where we will be using completing the square in a case where a equals 1. In the next video, we will be doing the case where a is not equal to 1. So, completing the square. What does completing the square mean? Completing the square does not mean that you draw in the fourth side, right? That is not what completing the square is. Completing the square means you're going to find out what number, x squared minus 4x, where I'm going to bring that 14 over to the other side. What number do I need to add to this side? And then I will also add to this side. What number do I need to add in order for when I factor this side, that I will get two of the same factors and I can write it as something squared. So like what we saw in the very last part C of example 2, when you have a quantity squared, then you could solve by taking square roots. And then that's also, like I mentioned, while I was coughing up a storm in that last video, you don't want a linear term floating around if you're going to be completing the square. Or I'm sorry, solving by square roots. However, if it's written as a quantity squared, you could have that linear term sort of hidden away, and we could solve by taking square roots, which is going to make it easier for us. Otherwise, you can't solve a quadratic unless it's factorable. So how do I know what number needs to be here? Well, let's kind of think this through, right? Here, x squared. That's easy because the a is 1. I know that that has to be x and x, right? Next, the minus 4x over here. Well, that tells me that I need to have minus 2, minus 2. That's going to happen. That will get me the x minus 2 quantity squared right there. Well, how could that happen? The only way that that could happen is if this minus 2, right? What's last times last going to equal? What is last times last? That's going to be that magic constant that we want to add. So that's going to be the magic number that we're going to add right over here. But again, whatever you do to one side, we obviously do to the other. And we can add a constant. No big deal. We're not dividing by 0 or any other dividing out a variable or any other nonsense. So what's that number going to be? In this case, that number is going to be 4, positive 4. It'll always be positive because it's either going to be a negative times a negative or it's going to be a positive times positive, right? Because they're twins, you know? So I'm going to add the same number to both sides. That gives me on the right side 18. And now I can use completing the square to get me into the position that I'm in right now, which is allowing me to now solve by taking square roots. Solve by taking square, that's not an R, roots. Okay, so we're going to solve by taking square roots. So let's go ahead and boom, 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 boom. Don't forget the plus minus. Now I have x minus 2 equals plus minus square root of 18. X minus 2 equals square root of 18. That's 9 and 2. Square root of 9 is 3 plus minus 3 root 2. And then add that 2 over to the other side. X equals, let's make it in front, 2 plus minus 3 square root of 2. So how do I do this? I bring over the constant that was here. Well, not that. I bring over the constant that was there. So I get just my quadratic and linear term on one side. Then I start factoring. This is, to me, the more logical way. You probably learn find b, what's half of it, square it, add that number to both sides. Great, cool. But let me show you like a better elaborate why it works. I want the factors to be the same. I know x squared has to be xx. And in order for the outer and inner to make negative 4x, well, what's half of negative 4x? Negative 2x. So that means my outer and inner, when I FOIL, are going to make negative 2x. So I need negative 2, negative 2. That gives me x minus 2 squared. Backtrack. What would the c be in ax squared plus bx plus c with that situation? It would be 4. That's the number we add to both sides. Boom. Beautiful. I hope that was helpful. I hope you're like having an epiphany right now of how to use completing the square. We're going to see an example next in example 4 where a does not equal 1. So check that out. because you should be curious. And I will probably, I don't know when, maybe after that, do the derivation of the quadratic formula with that, which is beautiful. So check the playlists if they're helpful. Find more of what you're looking for. That's it for now. Adios. Oh, thumbs up. Don't forget.